Hello, everyone. My name is Russ Waddell. I'm the Managing Director for the MTConnect Institute. Thanks for joining us today. We have a nice presentation prepared from our good friends at Beeond Incorporated. They have prepared a brand spanking new toolkit for MTConnect plus OPC UA, EdgeXConnect. Our presenter today is my colleague, Kaz Pipero. Kaz has a varied and illustrious background in industrial automation and systems. He has many years of experience in both solar power and industrial systems integration and automation, specifically for manufacturing, process, and energy. He's got a impeccable standards background working with OPC UA and ISA 95. In addition to his extensive publishing, books, articles, so on. He's a co-founder of several companies over his career, and he is also a established and well-regarded coach and teacher and instructor for all sorts of industrial connectivity projects. So Kaz, thank you so much for being with us today. A couple of notes of housekeeping for everyone on the webinar. We are now in the third of a series. So the background information on why MTConnect and OPC has been presented in two previous sessions. I'll put a link to the recordings for those sessions into the chat window once I'm done talking here. The third session is about tools. This will be an ongoing series. There will be more of these in the future. They're likely to have some more from Beeond, as well as other partners and product developers. So stick with us, and thank you for coming in and your interest in OPC and MTConnect. We look forward to what Kaz has to share with us. And last thing is I would say hold your questions till the end. You can use the raise hand feature or the Q&A feature or the chat feature. If you type a question into chat, I'll move it over to Q&A. If you can find the Q&A button, just punch your question right into the Q&A field, and we'll get to them once Kaz has wrapped up the demo. With that, Kaz, I appreciate having you here today, and I would like to turn it over to you.
Thank you, Russ, for the gracious introduction. Good morning, good afternoon, and good evening, everyone. My name is Costantino Pipero. I'm with Beeond Incorporated. I appreciate your participation to this webinar. I'm here to present you a demonstration of one of our products called EdgeXConnect, which is designed to allow users and engineers to integrate OPC UA within their current solution sets. OPC UA is a standard that has been around for more than a decade now, and it's the evolution of the OPC standard, which started in the late 90s. That's when I started using OPC. Then the foundation created OPC UA as in universal access, overcome some of the limitation of the OPC Classic standard, and it's been around now for a while. The current version 104 has 14 different parts. The OPC UA standard is very powerful, yet is very complex. In fact, the incoming newest release 105, which is months away from the actual release to the industry, will include 22 specifications, which is thousands and thousands of pages that cover the various aspects of this kind of integration, from I/O mapping to information modeling to security to alarming and different networking options and so forth. That makes OPC UA a desirable interoperability solution for end users, but it does require some effort in terms of learning curve and development and maintenance time. Now, we know that because that's our core business, and it's been our sole business since 2014. That's why we decided to gather the common aspects of OPC UA and make it into a configurable product. what is EdgeXConnect? At a high level, you can see in its current manifestation, EdgeXConnect is a configurable OPC UA server, which has the capability to relay any information from the underlying system into an OPC UA packaged dataset that can be connected to by any compliant OPC UA client. And it hides the complexity of actually having to develop an OPC UA server, yet it will include all the capabilities of the OPC UA requirements, such as the address space management, the information modeling, the security, and the networking options. The characteristic of Ajax is that there's no software development required to install and use Ajax and to map it to an existing solution. We will provide a library of adapters to interface with the common device protocols, but we also provide an adapter SDK to extend it to interface to proprietary systems. Ajax runs on different operating systems from personal computer OSs like Windows and Linux to embedded Linux systems and ARM processor-based solutions. It's very fast to install, very easy to deploy, and it will definitely significantly reduce the time to integrate an OPC UA solution in your current application. The components of EdgeXConnect are a GUI that will allow users and developers to manage an EdgeXConnect deployment. It will allow the user to actually create an address space, create an information model, or import an existing companion specification like we will do today with the MTConnect as an example, a companion specification that can be integrated with the EdgeXConnect. Then there will be the EdgeXConnect server, which is actually a set of services that run on the target device, and it will integrate to an existing protocol as a Modbus driver. In the case of today's demo, we will integrate with a LinuxCNC driver that we created to talk to that specific solution. The adapter SDK, as I mentioned previously, it can be used by developers to actually create custom plugins for proprietary protocols or integration requirements. EdgeXConnect is designed to live at the edge, as we know it now, which is that part of the deployment stack that relates to the shop floor, field I/O, and that level of integration. But it can also live at what we commonly call level 2 and level 3 system as per the ISA categorization. So it can live on a SCADA or an MES systems. That's why it's designed to be deployed on different platforms. Typical applications are such as embedded systems that specialize on specific functions like controllers or smart I/O. They just need to relay their values into the OPC UA world. It can also act as a gateway to basic translate from one protocol to OPC UA and vice versa. Or it can live in an upper level where you have a more complex software solution like a SCADA system or an MES system that needs to interface via OPC UA to a higher level system like a scheduling application or a planning or warehouse management system. So as far as the components, high-level components of EdgeXConnect is a set of services that communicate to each other. They are deployed on the target machine, and they basically lay on top of an existing solution. Say you have your own protocol, your own drivers, your own system of interfacing or getting input and output information. The I/O mapping service will basically allow EdgeXConnect to interface to the specific existing solution. And then there is an address space management capability that basically can correlate an OPC UA information model to those raw values coming from the underlying system, and it will create OPC UA nodes that can be accessed by OPC UA clients following the data access specification that will allow the users to actually read and write and subscribe to OPC UA nodes that are mapped to the existing solution. And then of course there's the capability as per the OPC UA specification to handle methods. And EdgeXConnect actually has this unique feature that the user can actually script the method handler in a scripting language within the configuration. And on top of that, of course, everything is wrapped around the secure channel model, which is basically the communication can be signed and encrypted, and the user access can be authenticated and authorized by the server, so that will meet the security requirement for the OPC UA compliance. Around all that, the product can be extended with an adapter SDK in case the underlying system is a proprietary system, so the adapter needs to be created. Development of adapters do not require knowledge of OPC UA. It's a very simple API. The developer only has to know how to interface to EdgeXConnect, which is quite a handful of API. It's probably 12 to 13 APIs to know, and that's going to be the entire SDK. As far as today's demonstration goes, what I'm going to show and perform is the deployment of an EdgeXConnect into a Linux machine. Now, the Linux machine is basically a LinuxCNC image, which is a Debian image that runs the LinuxCNC system. Most of you that are better educated on numeric control than I am will know the LinuxCNC as a system, open source system that can connect and control several numeric control solutions, and as in my case, it can definitely simulate one. So we actually created an adapter for the LinuxCNC. So we're going to deploy EdgeXConnect on the very same image, and then configure EdgeXConnect to use MTConnect, the OPC UA specification for MTConnect as an information model. We take that model and create an instance of a few IOs that we will map to the LinuxCNC IO. It's a 3-axis machine, so we'll have the axes mapped according to the MTConnect specification, and it will also allow the user to not only read the axis position but also write a command and also invoke a method. And we will do that by using a very generic OPC UA client to connect to EdgeXConnect to demonstrate all that. So without further ado, I'm gonna start up my Linux image, and we're gonna go into the details of the MTConnect integration.
So the LinuxCNC machine is a VM. I pulled the image out of the LinuxCNC website. It's already pre-packaged with LinuxCNC. I ran the simulator of this 3-axis router. I home the tool, everything seems to be working. So now that I have a Linux VM running, I can go ahead and access its file system. And that's where I launched the shell from Windows. In this case, I'm pretending to be a system administrator. So, and from the Linux shell, I will then look for the package that I previously downloaded with all the EdgeXConnect artifacts and launch the script that deploys it. As I said, one of the reasons why I recorded the video besides the mishaps is because on my machine, this deployment would take about 6 minutes. In this particular instance, the system goes to the internet, downloads the artifacts for the operating system, and then installs EdgeXConnect. If the system was not connected to the internet, there's also an offline installation process. In fact, I can actually skip this. To the point that, there you go. So after a few minutes, the system is installed. I access another GUI here. It's a terminal GUI that system administrator would use to look at the health of the system, make sure that EdgeXConnect is deployed and it's running. And it's running with its empty configuration, but I just want to make sure that everything is healthy, that resources are not overwhelming. I don't have any error, and that's the point where I will move out from the shell into another machine where I will proceed and configure EdgeXConnect to represent my objects. And to do so, I actually open my development machine where I have my Ajax Studio, which is a graphical tool. It runs in Linux or Windows, and it's basically a way to model the address space and configure an EdgeXConnect server and deploy the configuration for users. In this case, I prepared a project in which I have my model where I added the MTConnect companion specification. I'll show you in a second how I did that. And I can see the MTConnect namespace. That means that among the types, I will also find MTConnect objects or type definition that I can use to create my CNC interface. For those who are familiar with MTConnect, you probably noticed that this is version 1. There's version 2 has been around for a while. I actually happen to use version 1. I look for a controller, controller type, and that's what I did in Ajax Studio. I configured my device, called it my CNC1, and my CNC1 is of type MT controller. So it has a lot of variables and properties that comply with that specification. Plus, I added 3 axes, X, Y, Z, to be mapped to the specific I/O point, and then a running command, which is a bit that I flip to stop and to pause and restart the simulation. And here you see that I'm mapping the axis X to a device. The devices are relative to the adapters that I deployed on EdgeXConnect. The LinuxCNC adapter, I control the configuration. The only configuration required for that is the NML file. And I will then map the I/O to that device. You can see that I do some cut and paste and some typing. The mapping data will be a specific format for the LinuxCNC adapter that basically qualifies the variable that I want to access on the underlying system. At this stage, with this beta version, We still have to type the JSON in the mapping data. The GUI will be enhanced to avoid that, but the functionality is that an OPC UA variable will be mapped to an underlying system device, will be saved, and then I can go ahead and configure my method. And the methods are that part of OPC UA where a user can model a method with input and output arguments. But in EdgeXConnect, you can also add the logic of the handler. And we use a scripting language in which we take the input parameters and we create, we operate a summation, and then we send the result as an output. This is a very simple example / tutorial that we use for method scripting. But of course, in EdgeXConnect, the scripting can do a lot of things like accessing the address space, aggregate, calculate aggregation, and do anything that you might want to do with some criteria. Let me just go back. I show here how to add MTConnect information, component specification. Right there. In order for me to import the specification, I just take the node set from the GitHub or the MTConnect website, and there's a node set can be imported in the address space, and once it's in that address space, can be used. Last thing is taking care of a few system parameters. I default mostly everything. The one thing that I want to know is the OPC UA port that the server has to listen on, and it's 54,000. So I can go ahead and upload the configuration to EdgeXConnect. And once that's done, that's completed. Now, I've done these before these presentations, so now I'm going to go to the live system. This is the actual system that the video was referring to. Now, this LinuxCNC image has EdgeXConnect running. Therefore, I can take an OPC UA client. I use UA Expert. Let me just use some real estate here. And I can actually start the simulation here. And as a client, I can connect from my Windows machine to the virtual machine. I already typed the server endpoint. I decide to connect securely using these algorithms. My user, which is pretty powerful. Credentials are here. Edge. Powerful in that I can write to the running flag. There you go. These messages you see is because my certificate is a self-sign and has local host instead of a domain. So UA Expert complains, but it's a minor warning. There you go. So now I can see the server address space with my devices. I see my CNC object. I will subscribe to the 3 axes, which are showing the values that you see on the other side. I can also see the running flag. I can write. I cannot write to the axis. Those are read-only. The running flag will write back, and it will stop, in fact, pause the simulation on the remote machine. And if I set it to true, it will resume. The last thing is the method. You saw that the Lua script implemented a summation of 2 arguments. And so the client can see that model and expose 1 plus 4. I call the method, you get 5. Nothing too impressive, but the ability of the user not to have to create any custom code other than the scripting itself to implement methods on the underlying system. And that's basically the end of the demonstration. If you have any particular question, I guess I'm ready to take it. The one thing that I might show on the screen is this slide, which has the components of an EdgeXConnect cluster, which has a set of containers. Some of them will take care of what they're called the cross-cutting concerns, security, logging, and internal IPC mechanisms that we use to talk to the services. And then the services that you saw. The one part of the extensibility is that the users can implement their own adapters to an adapter SDK, and they can also interact with the EdgeXConnect using our own RPC SDK, which will be able to communicate to the service. For example, the Ajax Studio GUI tool that you saw that we use to model and configure the system uses the RPC SDK. All right, should I look at the questions myself? Let me see.
Cause, I'll repeat them out loud for you. So we had a couple people that were asking about trials or trying to use the tools for themselves. Is there anything they can get their hands on at this point?
Okay, so what you're seeing is a pre-beta. We are launching our beta program at the end of July, so in a number of weeks. We're trying to wrap up, especially the GUI part, and then the target launch is October 2021. If you go to the product page, you can see some of the information about that, and you can contact us if you want to get your hands on the beta or function as early adopters. But fall is our launch, our go-to date, for the launch of the product.
Cause, the next question was about validation against the more recent version of the MTConnect companion spec. So it's a two-part question. First part is, are there plans inside Beeond to try and rev this for the new companion spec? And number two, is this something that can be reviewed in the OPC MTConnect joint working group for revision to the newer companions?
Oh, absolutely. Just to be clear, we don't have to develop anything additional to comply with the new specification. It's just a configuration effort. It just so happened that my modeling, I had the previous node set, not the newest node set, but creating an address space with the newest version is just a matter of going back to Ajax Studio, load that specification, and map the variables accordingly. That's the one of the compelling arguments for EdgeXConnect is it will take, I guess, any specification that is compliant with OPC UA, and it will instantiate it. So maybe one thing that we can do is shoot a video that we're going to post on our website with the version 2 to avoid confusion. But EdgeXConnect can basically load several component specifications even at the same time. That's actually a characteristic of OPC UA, not just EdgeXConnect.
Kaz, you got one more question here. Do you have any comments about the LinuxCNC HAL hardware abstraction layer while developing Ajax?
Actually, I didn't come to any particular appreciation of the hardware. This is the simulator. Maybe the question was relative to, we had to actually write our own, an adapter for it using the adapter SDK. Let me go back to that slide. And in doing that, we implemented, the adapter SDK, just I failed to say it's a C++ adapter. So we use the NML interface. It took a minute. Russ remembers, especially for us that are not very CNC aware. But then it just matter of understanding the NML aspect. So if you know your domain, the adapter SDK is pretty straightforward. If you don't, also keep in mind that sometimes you want to write your own adapter, but other times maybe the system has an OPC Classic, a Modbus interface, or things like that. But I don't have any other personal observation about LinuxCNC other than it's a convenient way for me to simulate a router.
We've had a similar experience. I can't speak to the exact question about the how components, but the LinuxCNC documentation is all public and open, which makes it very straightforward for writing an MTConnect adapter or an adapter agent combo. We happen to have a piece of hardware that runs LinuxCNC with a machine kit variation to it, so that was one of the reasons we picked it. But the documentation is good. It's free. It's complete. It's all the data items you would need. It's a very easy simulator to use.
Yeah.
Kaz, one more question. What adapters will be available when you release in the fall?
So as of now, we have, well, the LinuxCNC is kind of a dedicated adapter per se, but there's Modbus RTU, Modbus TCP. There's OPC UA, meaning that EdgeXConnect can talk to another OPC UA server. It can talk to an OPC Classic system. And then, well, that's basically what we have scheduled until the end of July. We are looking at Ethernet IP, of course, but we might not have it by October. So,
related follow-up to that. Oh, sorry, I didn't mean to cut you off.
Oh no, just incidentally. And the reason is that we have a few customers lined up for early adoption. So we have to go to a list of requirements. So Ethernet IP and Profinet will be next in line, but I'm not sure that we'll be ready by October.
A related follow-up question asking
Correct.
whether Beeond provides a service for creating specific adapter domains.
Of course, that's the obvious answer. We would do anything for money, but yes, no, we are. That's actually it's been our primary work to actually develop OPC UA systems. So yes, we would provide service to create specific adapters, especially for those that are not standard. They're proprietary interfaces. We can either write the adapter ourselves or even train the customer team to write an adapter.
Quick comment on that. You guys are looking for early adopters, right, in August?
Yes.
Link the email address, or do you want me to stick just the contact page from the website? What's the best way to get in touch afterwards?
The best is the contact page. We go to the right people. Actually, I haven't been to our website in a while, but you can contact us here. It's beeond.net.
Next question for you, Kaz. In the demo you just gave us, was the connection from SIM to the OPC UA server MTConnect or something else?
Oh yes, that's a good. I think that so it is OPC UA, meaning that there's no MTConnect adapter in between. This is basically the OPC UA server modeling its address space according to MTConnect specification, but the communication happens via an OPC UA channel.
Yeah, this is Stan. I'm also from Beeond. I just wanted to, I guess, make it clear the adapter SDK is an important part of EdgeXConnect, and certainly a key target market for us, and one that we've been doing a lot of projects for are equipment manufacturers that want to add OPC UA as a standard to their equipment, their devices. And so we're kind of taking services away from ourselves, but the idea is with EdgeXConnect, you can with an adapter really connect to any proprietary API interface that your equipment may have. So that's really where the connectivity extensibility comes in.
And Stan, we should add that you're the co-chair of the OPC MTConnect Joint Working Group, which is responsible for creation, maintenance, and upkeep of the companion spec that was used to get all this stuff working. So thanks for your long-standing volunteerism in the MTConnect Institute and OPC Foundation.
Oh, thank you for that.
Kaz, do you have any last words for us? That's it for the questions.
No, I don't have anything. I mean, thank you again for the time, and of course, feel free to contact us. We are looking for early adopters, and we'll definitely be following up with any other questions that we might receive.
All right. Well, thanks so much,
you,
Kaz and Beeond, for preparing this material and for presenting today. Thanks for speaking. Thanks to everyone who attended and had questions. Thanks to AMT for hosting, and we look forward to hearing again from all of you as this continues to develop. Have a great day.